Audio. Oh, now is it working? Yeah, hello, hello. What do you think? Is it working now? Hello?
Hello.
Okay, good. See, there's so many buttons to push. And I'm an absent-minded professor, right? So thank you. See, he saved us from having the sound not working. I was so focused on getting it to test because I had to change which mic that we didn't even turn the mic on. All right. Any other questions about anything?
Recursion kind of like a foundation for dynamic programming?
Yes. Yes. But we're not doing dynamic programming in this course. You have to wait for 3101. All right, so recursion is how many people know recursion already? All of you. Excellent, most of you. So recursion is a program that calls itself, right? And which seems pretty absurd that you could write a program by assuming that you have a program, but we'll get into that. And why do we do it? There are two main reasons. The one is that the running time can sometimes, bizarre reason, be faster, right? If you were to write a sorting algorithm, just you think of a sorting algorithm, then it's n squared time because you're bound to compare every pair of numbers, and they're n squared pairs of numbers, right? But merge sort, quick sort are all n log n, and that's worth doing, right? The other reason for doing it is that it can be, the recursive code could be surprisingly easy, while the iterative code could be very complex, right? Yeah.
And that recursive could be faster.
Yeah.
That's compared to what? Because my understanding was that the iterative version of recursive code is always going to be faster.
Yes. Yes. Absolutely. Absolutely. So if you design on the top of your head an iterative algorithm for sorting, you would probably do something like insertion sort or quick sort or bubble sort, and those are n log n time, right? And then if you were to sort of conceptualize recursion, maybe you would come up with merge sort and quick sort, and they are n log n time. Now, but recursion has overhead, right? And if you were to sort of take your recursive code and turn it into iterative code, it would probably run faster, right? And how would you do that? Well, you would need a stack, right? Now, I don't think you should do that. Why? Because any compiler worth a good compiler will take your recursive code and turn it into iterative code that runs fast for you, right? I'm pretty sure modern day compilers do that. All right. So that's not a good excuse anymore. It's my, anybody know about that? That's my take. Right. But I'm not a computer guy, so don't ask me. All right. Any other thoughts about recursion? All right. Oh, so the other thing I was saying is that thinking about it, the recursive algorithm is sometimes easier, right? Like I don't know how you would come up with an n log n time algorithm for sorting if you weren't thinking recursively, right? You just wouldn't write that as an iterative algorithm, right? So, and the other classic example, so my girlfriend was working on Towers of Hanoi, you know, she was getting flustered. Have you ever done Towers of Hanoi, right? It's really hard to do it iteratively, right? And the recursive algorithm is trivial, right? And so I was spending some time thinking. In fact, I think I even spammed you guys on that, didn't I? Yeah, right? So it's gotten better. That if you wanted to read it, that document's gotten better because it's how to think about something that's an obvious recursive algorithm, how to think about it iteratively so you can actually do it. And it's much harder, right? All right. All right, so Fibonacci is a classic. Everybody know Fibonacci numbers, right? It's a sequence of numbers that you should have learned in 1019, if not earlier, that it's a sequence of numbers where every one is the sum of the previous two, right? And it comes up in the golden ratio and in all of those applications, right? It comes up a lot. And so one can easily write a recursive algorithm for it, right? I mean, there's your recursive algorithm, right? What's the nth Fibonacci number? Well, if n is 0 or 1, then we can start off with being 0 or 1. And otherwise, it's the sum of the previous two, right? And you can see it's a program that calls itself. And there you have it, right? And so if you were to trace this out, on 8 it calls 7 and 6, so on 7 it calls 6 and 5, and you get this big exponential size tree, exponential running time. And how do we feel about exponential time? We don't like it, right? We don't like it. So it's one of the problems is it's easy to write programs that take exponential time, and you gotta watch for that. In fact, Paris, Hanoi is exponential time, because that's just what it is. So, and have I talked about this? I talked recently about my religions, about recursion, I think already, right? About trusting your friends. This is, you don't try to understand this whole computation, right? You give your friend an instance that's smaller and meets the precondition, and you trust them to do it, right? Because this tree is about as easy as it's going to get, and it already looks pretty crazy, right? You don't want to understand this tree. That's one thing. And then he was asking about dynamic programming, right? Which is, if you look at this and you see somebody, let's look at some number, 3, right? Somebody calculated Fibonacci of 3, right? But it wasn't done once. Look how many times 3 is in the table, right? And that's why it's exponential time. And so dynamic programming would say, assign one person to solve 3 and only do it once, all right? But we're not going there. So, right, this says don't understand, right? I mean, in this one, there's even a cooler equation for Fibonacci numbers. And you might say, why is there square root of 5 in there? All right. Did you guys cover that in 19? Yeah.
Yeah, but strong deduction. Strong deduction, you come up with that formula.
Yeah, you could do strong induction. I would do it differently. Anybody who wants to see a nice, easy proof of this, I can show it to you, but it's not part of this course. All right. This Andy is another teacher, and I stole these slides from him. And one of the ways you'll be able to say is it has more code than I like. But suppose you wanted to print out a ruler like this, then you can start with a routine that tells you the location up and down and how many dashes you want. So here we're down a quarter and we're put 3 dashes, right, to make that where we circled, right? That's what that routine does. And then you could, this code prints the 0, the 1, the 2 up to 12, right? And we're focused more on how to fill in the stuff in the middle. All right. So that's the draw interval. So here's the stuff in the middle, and let's see how we do it. So one thing let me emphasize is that pre and post conditions are always important because you need a contract, right, between the who's using it. But here it's double important, right? It's double important because not only do I need to know how to make my boss happy, right? What is my boss going to give me precondition? What's the post condition I need to give back to my boss? Not only do I need to do that, but I need to talk to my friends, right? I need to know the precondition of what I can give to my friend and the post condition of what I can expect back from my friend, right? So it's double important. And sometimes it's what you can do is if you want to give more things to your friend, more information, or get your friend to do more things, you can change the pre-post condition, right? But once you've done it, you have to do it too, right? So anyway, what are the precondition here? And I can get less manic and talk slower, right? So there's an interval that you're printing on. And here we're filling in from 0 to 1, right? And then there's the length, which is the length of the guy who's going to be in the middle, right? So we're going from 0 to 1, and in the middle we put 4 dashes, right? Everybody get the pre and the post condition? Yeah. So then how do we do it, right? If length is 0, then there's not much to do, right? There's nothing to print at all. We're done. So we go home. And so this code doesn't actually have a return. It's just going to fall off the bottom, which I suppose automatically returns. I've never written code without a return line, but I suppose it does, right? Otherwise, what do? We calculate the middle, right? The middle is where the 4 dashes are, and we can calculate that height, and then we right, then we draw this stuff, right? And how do we draw that stuff? Well, it's sort of a smaller instance of the same problem, right? It goes, where are we drawing it from? We're drawing it from 0 to the middle, right? From A to the middle. And what's the length of the guy in the middle? Well, ours was 4, so it's going to be 3. It's 1 smaller, right? So you see what we're giving our friends is go from A to the middle and have the length be 1 smaller, right? Does that make sense? Right? And then we personally do some work, right? We personally draw these 4. And then I have a second friend who draws from the middle to the B, also 1 less. Right? Everybody get that? Oh, yeah, so here we call it. And oh, so here's just the question of this is, I called it on, maybe I lied to you. Maybe if this says 5, then that's the outer one, not the middle one. Close enough. All right, so here, what does 6 do, right? Well, 6 is going to put in these extra dashes everywhere, right? Puts in extra dashes, and then it recurses 1 more time, right? All right, so I was about to say something meaningful, then I forgot. Oh, it's gone. It's gone. Wasn't obviously not that important. Any questions about that? Oh, I remember what my brilliance was. I told you that there was 2 reasons to do recursion, right? It was, it could be faster, it could be more intuitive, And the third reason is that what you're working on might actually have a recursive structure, and hence recursion is the obvious way to go, right? So this, in this case here, right, it just looks recursive, right? And even if you go back to Fibonacci numbers, well, we don't need to go all the way back. They also look recursive, right? So it's the natural way to go, right? All right, everybody good? Any thoughts? Are we going too fast? You can slow me down. We're good. All right. So I'm supposed to teach you code, and I'm not a coding guy, right? So I'm going to avoid code as much as possible. But for this course, we'll throw in a little code. And if you remind me, I can try to get some markers. So if you really need code written, maybe collectively we could do it. All right. But you know, I read this and I don't want to, right? I don't want to read this. I don't want to write this, right? But one thing is true, a recursive program calls itself, right? So if you look up, what are we writing, right? We're calling merge and sort. So merge sort. Merge. Yeah, I guess the routines merge and it's calling merge there. I don't know. Anyway, it recursively calls itself, right? And right, I know you guys need code because that's you want to be a job to write code, and we'll look at some code, right? Right now, what could you do instead? Right? You could do some pseudocode, and it's a little better. You know, the amount of just stuff that Java makes you put in there, it's enough to make anybody go nuts, right? But that's not what we're doing. Yeah. Yes. That's a good question. That's a good question. I don't have a good answer for you. All right, so no, don't panic. Don't panic. What I think about is I said this before, if you're standing in a subway and we're chatting about an algorithm, then how would we chat about it, right? I claim we would chat about it at a higher level of an intuition, right? And I believe that I'm good at teaching people how to do that, right? And so I hope with these slides, it'll teach you how to think about recursion. And then you have to think about how to write it down. Then I feel all you need is the syntax to write it down, right? And to work out the details. And if you have a syntax question, I'm probably not the person to come to, right? But as a class collection, we could do your syntax or we could Google it. And if there's some little coding details, we could talk about it. All right. Yeah. So for the written tests, you need to be able to think at this higher level. For me, at least, you think at this higher level of abstraction. Jackie is more of a code guy, and so the good news, I guess, to answer your question, is he's going to give you 4 practice coding things, which are more 5 marks each, I think, something like that. And to get the full marks, I think, I could be wrong, but if you hand in an essay about Shakespeare, you'll get the marks. I know that's my understanding. You just have to hand something in. Is that the way you read it? You might check with other people, but that's my understanding. All right. And there, if you're not knowing how to do it, then we can pause class and collectively try to figure out how to do it, right? And so what you need to be able to do is make sure you know how to do those 4 exercises. And then there's going to be 2 tests in a lab. So there, I would say by then you should have memorized the syntax of Java enough that my understanding is that what the test is going to be is more or less the same level as the practice, so that if you did the practice, you'll do fine on the tests, right? Right? So if you want to practice for the tests, right? Even if somebody gives you the answer for the practice, here, in fact, let me tell you, there are various levels of cheating, right? And one of the reasons I don't have assignments anymore is because I just assume everybody's going to work together, right? And so one level of saying cheating is if you talk to anybody, then we will get you, right? That's one level of cheating. Another level of cheating is talk to whoever you want, even the professor, and then before you hand it in, put all your notes to the side. Might be before your time, but watch an hour of Gilligan's Island, and then can you write it up by yourself without looking at any notes, right? I mean, I would say minimally for any assignment you ever get, you should do that, right? You should say, can I clear my mind and write down the answer, right? Because that's what you're going to have. Then the test comes, right? And you have to be able to write it down. Are people okay? I think I'm glad Jackie's handing the code because I don't like the code, and I think we'll manage, right? We'll get through it. I don't think yeah.
You have the same coding test as Jackie's class?
I'm gonna say no, and the reason is because we can't get a room that everybody can be in at the same time. And if one class does it, then the information gets out to the other classes. So my understanding is that poor Jackie has to make up just a whole lot of tests for the 4 sections, right? And my understanding is he's going to make them all up so they're same enough but different enough. Yeah, that's my understanding. People feel okay about the coding? And we'll do some coding. We can do some coding. Like, for example, I want to spend a lot of time on pointers because I think people get pointers wrong, right? They just do pointers wrong. And I happen to know that there's at least one of the assignments is on pointers because he told me a date by which I had to cover it. All right? There's a date by which I had to do recursion. So let's count on that first assignment being on recursion. And there's a date on which we have to do pointers. All right? That's all So I think we can learn this material, and I think we can learn to code, right? I don't think that coding is the block, right? In understanding materials.